Hi guys, welcome to Learn Tech from Zero. Today we'll be covering further CCNA topic. If you're new to this channel, we offer free courses for anyone who's interested in IT. So on our website you can find all those high demand courses completely for free. You can go through the notes and quiz and etc, so it can help you practice and get ready for those examinations. Like for example, we have CompTIA A plus, Microsoft Azure for networking. We have CCNA, CompTIA Network Plus, Cloud Computing, AWS, Azure, Cybersecurity, Security Plus. All these courses will be free for anyone. Not all the courses are completely ready, but we are working on it and they will be ready very soon. So let's begin with today's topic, which is we'll be covering CCNA topic. So let's just go in CCNA, and then today we'll be covering compare TCP and UDP. 1.5 compare TCP and UDP. I'm not going to go through all the details, so if you want you can just go onto the website and learn them. What we will do is I'm just going to give you a quick overview, and we will just practice those quiz at the end just to have a good understanding of this topic. Alright, so let's begin. What are TCP and UDP? Both TCP, Transmission Control Protocol, and UDP, User Datagram Protocol, and transport are transport layer protocols in the TCP IP model. So in the TCP IP model, if you're new to this, if you don't know what TCP IP and OSI is, and you don't know what transport layer is, then you need to go back and start from the beginning. All right. So let's say in the TCP IP model and OSI model, it's in OSI model it's in layer 4. So you can see that for all the reference in real life IT environment, the reference is always always the OSI model. We don't say it's layer 3, we say it's layer 4, because 1 2 3 4, so it's a layer 4 protocol. OSI model helps you, basically that's the way of transmitting data from one device to another device. So it goes from application through all these layers to the other computer, the receiver's end, and they receive everything through physical data link up to the application. That's where the user stands. So in this topic, TCP and UDP, we'll be covering layer 4, 1 2 3 4, transport layer, and transport layer is mainly TCP and UDP. So what they do is they will make sure, rather than me just giving you a explanation, let's just go through some of the notes. So in TCP, so their main job, both TCP and UDP, their main job is to control how data is sent between devices over a network. So they control how the data is sent from your computer to another computer. And when one computer sends data, the data passes through several layers, and transport layer decides how the data is delivered. So all the data from your device to another device, the the transport layer, TCP and UDP, they decide how the data should be delivered. All right, let's start with TCP. So TCP, all you need to understand is TCP is very reliable and UDP is unreliable, but it's really fast. When you need guaranteed transmission, when you need the data to be transmitted in order and all the data must be transmitted, then we use TCP. And for something where you don't need guarantee, like for example, let's just use an example. TCP, let's say you are browsing a website, it has to be TCP, otherwise you will not get the complete details. The website will not load properly. Not all the information will load properly. So TCP, what it does is it guarantees data delivery, and it will make sure that all the data is retrieved or delivered. Okay, it guarantees all data is received in correct order. Corrupt data is retransmitted. So if anything is corrupt, any file is corrupt, it will make sure that it retransmits, and all the data are being sent. These are the features of TCP: connection orientated. They do a three-way handshake to make sure so basically the connection before we basically establish TCP connection, they do a three-way handshake to make sure that a secure connection is created. Let me just show you an example. So the sender will basically send a synchronization message, so scene message, and then the receiver will send a response saying that they acknowledge the synchronization. And then what will happen, the sender will again acknowledge and confirm that okay, the connection has now established, and this is when the data will start transmitting. And with UDP, it's just straight sending and receiving. It requests, it responds, it requests, it responds, etc. All right, so you can just go through them later on. I don't want to go through all of this, and you don't need to be an expert in TCP and UDP. You just need to know what layer they fall on, and then the basic characteristics of TCP and UDP. So I have provided extra information. Just go through them, and then everything is right there. Three-way handshake, how the connection establishes, it's all right there. For example, of TCP cases are web browsing. That's I've explained to you before. If it's not TCP, you will not get the whole information. There will be missing information. So TCP, if something doesn't load, it will keep on reconnecting. Basically, it will keep on requesting until all the sequence are in order, and then it can display everything in order. Email, you can't be receiving half email and not the complete email, just half email. You need a full email. So this is where TCP comes on. File transfer protocol, if files are not transmitted properly, then the files will be corrupted, so it has to be TCP. Let's just use some UDP example. UDPs are connectionless, no handshake, nothing. It's just the connection starts straight away. Unreliable, no ordering. It keeps on just sending and receiving. No ordering, low overhead. Just go through them. I don't want to give an explanation of all these right now. And then, so what are the cases of UDP? For DNS, we have UDP. For DNS, from IP address to a website name, website to an IP address name. DHCP for allocating IP addresses. Voice, so let's just use a real life example that you can understand. So for example, if you're using a telephone, let's say VoIP phone, voice over internet protocol, those IP phones, they use UDP, because if the telephone has to make sure that all the voices are delivered properly, if something misses out, it will try to just go back and try to send the same data. It's not going to work. Let's say you said hi and it did not get delivered, it will try to send hi again. So this is not the way it should work, because the person can repeat themselves. So in that case, UDP works really well, because you said hi, it just transmitted, and maybe this hi did not go through. That's it. It's a real time connection. So if you say hi, you need to say hi again to make sure that this time it gets delivered. So there might be some jitters and everything, but what it happens is, like, even for online gaming, the thing is, let's say something did not come to you, then what will happen is, if it was using TCP, you will start lagging. You will be in the same position. You will not be able to continue further, because you are waiting for something to be delivered that has been missed out. So with UDP, if something misses out, don't worry. Let's say you are playing an online game, and then you are lagging. Everything just stops, and then it starts working. And then what will happen is, you will be continuing from where you are. It will not try to deliver everything from before. So I'm trying to give you a simple explanation of UDP. I hope it makes sense. If you don't understand, leave a comment and I will be happy to explain it to you. So comparison, etc. Let's just go through some of the questions. Which transport layer protocol guarantees reliable delivery of data? Is TCP. They guarantee Reliable delivery, if something doesn't get delivered, they will try to retransmit it again and again. So it's TCP. Which transport layer protocol is connectionless and does not guarantee delivery, but it's really fast? It does not guarantee delivery, but it's really fast. It's way faster than TCP. So the answer has to be UDP. So when we say transport layer protocol, TCP and UDP, that's it. FTP, HTTP, these are application layer protocol. These are layer 7 protocols. All right. So it's the UDP. Okay. What mechanism does TCP use to establish a connection between two devices? They use three-way handshake. You need to remember this. This is really important. One of the questions will be about this 100%. It will sync and then syn act and then act. Basically synchronization, acknowledgement, and then again acknowledgement. So three-way handshake. All right. Which transport layer protocol is faster due to its smaller header and lack of reliability features? Lack of reliability. UDP, it's not reliable. And it's small header because it doesn't have too many data in it. So it has to be UDP. Anything that's fast, smaller, quicker, not reliable is UDP. TCP is slower than UDP, reliable, and then it uses more header, etc. So answer is UDP. Which field in the TCP header is used to keep track of the order of the packets? You can find those. You should be able to answer these questions if you go through all the notes. And the thing is, when we say track of the order of the packets are the data, the information. So it keeps everything in order. You need to know this. It's called sequence number. When we say TCP sequence, it basically puts everything in order. So it has to be sequence number. Remember this. Which transport protocol is commonly used for DNS queries? It's UDP. So you can see that UDP uses port 53 for DNS. Which feature does TCP provide to prevent overwhelming the receiving device? You can literally use English. If you understand English, if you speak English well, you should be able to. The answer is right there. Overwhelming is just maybe there's too many data. Overwhelming is just like too much. And then how to control a overwhelming situation? You control the flow. So it's simple. It's just flow control. What feature does TCP provide to prevent overwhelming the receiving device? It's flow control. I can answer all these questions based on my experience and then knowledge and the definition of those English terms. But if you're new, you have to make sure that you go through the notes, and then if you have any questions, you research or ask people around. If I start explaining every single thing, the video will be about 30 minutes, 40 minutes long. So it's flow control. Which protocol is ideal for real-time applications like voice or video streaming? If someone says something, you don't hear it, they can repeat. You can just say, oh sorry, I didn't hear, can you repeat? And they will just repeat. It will not try to transmit again the same information back to you. In that case, I've always said it's UDP. UDP is used for voice and videos. Which header size is correct for TCP? I think it's 20 bytes. We can just go through the thing. Hold on a second. TCP has a larger header. When we say header, we are talking about packets, and this is something that I will cover later on. But don't worry about it too much. So TCP header size is 20 bytes. So 8 bits is equal to 1 byte. So it's basically 20 times 8 bits. 1 bit is either 0 or 1. Okay. Everything is in binary, so you need to also understand binary. You need to know what binary is. Then everything will start making sense. And I will be also explaining binary in the next video. Alright, let's just go with the next question. So the answer is 20 bytes. And then, which of the following transport layer features is provided by TCP but not UDP? So what is provided by TCP but not UDP? Reliable delivery is right there, the first one. The TCP provides reliable delivery but not UDP. UDP and TCP both have the port number information, like where the information needs to go or should be received back. They have the checksum, they have the data segmentation, so it's all in the header, in the package. So we will be explaining that later on. So the answer is reliable delivery. So that's it. If you have any questions, just leave a comment and I will explain it to you. And thanks for your time, and I will see you next time.